Hello, this is Mr. Stansbury. I'm going to take you through the notes on finding a quadratic from its graph. At the end of this, you should be able to say, I can find the equation of a quadratic given its graph or multiple points. Example here, find the equation of the quadratic with the graph. So we've got this graph here, and what we really need to do in order to find the equation of a quadratic, we need three distinct points. So we have those here. We've got this point, and this point. So what we want to do with that is at -4, 0. This is at 2, 0. And this is at 0, -2. So those are our points. So what we're going to want to do is we're going to want to plug this into our little, we've got a nice little formula here. So the important part here is that we've got our two x-intercepts here. So what we're going to do is we're going to write y equals, there's going to be some multiplier out here. We don't know what it is yet, so we'll just write a. And then we're going to set these two here. We're going to have our two zeros here. So we've got this x here, which is -4, and then all we got to do is set this. What do we have to do to that -4 to make it equal 0? We have to add 4. And then for this 2, the 2 is in the x spot, so 2 and what gives us 0? -2. Okay, so that's how we'd start off. We're using the two x-intercepts. And then what we're going to do is this, we're going to plug in, we got one other point. We got, x and y here. So we're going to plug the 0 in for the x and the -2 in for the y, and that'll help us solve for the a. So we got -2 equals a times 0 plus 4 times 0 minus 2. So -2. This is a times 4 times -2. So -2 equals, 4 times -2 is -8a. So we divide both sides by -8. And we get that a equals 1/4. Okay, so we're going to use that a and plug that back in. So let's not actually circle that, but we're going to take that 1/4 and we're going to plug it back in for this a here. So our final equation here is going to be y equals 1/4 times x plus 4 times x minus 2. That is the equation for this parabola here. Okay, now we can actually also do this same thing with the graphing calculator. So I'm going to show you how to do that here really quick as well. And that's probably the system that we're going to use throughout the rest of them, because it makes it a little bit faster, a little bit easier. But you do need to know how to do one of these by hand, because the first problem on the assignment, we're going to have you do one by hand and then the rest by graphing calculator. Okay, so same idea here. We are going to use these 3 points to actually have the calculator find us a quadratic equation. So what we're going to do first is we're going to go into stat and we're going to edit. So we're going to do stat and we're just going to push enter for edit. And then we're going to edit these lists. So if you've got something in already, push clear in the main, in the top one there, and go down and it should disappear. So clear for that one, and that one's gone. All right, now here's what we're going to do. We've got these 3 points. So let's just list them. And we got -4, 0, 2, 0, and 0, -2. So what we're going to want to do is we're going to want to put this into the calculator, put all the x's in a row and all the y's in their corresponding spots there. So we got -4, 2, and 0, these 3. And then it doesn't really matter which order they go in, as long as over here in the list 2, whatever the y is for the -4 has to go in first. So -4 matches up with 0. 2 matches up with 0. Oops, not 2, but 0. And the 0 here matches up with -2. Okay, so now we've got all our data points in there. And then all we're going to do here is push stat. And we're going to go over to calculate. And this is a quadratic regression. We're going to do a quadratic regression line here. So we push enter there. And all of our x's are in list 1. All of our y's are in list 2. And we're just going to go down to calculate. There is no frequency list. Push enter. And it's going to find the best quadratic equation for that it can. So it comes up with 0.25 x squared plus 0.5x minus 2c. So we got I got to try to remember all this. So we got y equals 0.25 x squared. I think it was plus a half. Yep, plus 0.5 x plus 2, right? None of those were, oh, no, minus 2. Minus 2. And this is the same equation as that. If you were to FOIL this out and distribute your quarter, your 1/4 through there, you'd end up with this exact same equation. So same thing. Okay? Okay. Let's do B here, and we're going to do this with the graphing calculator as well. We've got this point right here. That is at 0, -9. We also have this point here, which is at 3, 0. And you're like, wait, we don't have another point. But we do have, if we make this little, there's the vertex right there. We reflect this over here. This is a distance of 3 to this line. So it's going to be 3 more from this line over to this point here. So that's going to make this point here at 6 and -9. So there's our third point. Okay. So use our graphing calculator. By the way, this r squared equaling 1 or -1 means it's a perfectly, like all the data fits perfectly into a perfect quadratic equation. Okay. So back into stat. We're going to edit, and we're going to put all of our x's in the x list and all the y's in the, sorry, x's go in list 1 and the y's go in list 2. Okay, so x's are 0, 3, and 6. 0, 3, and 6. And then the y's are corresponding y's -9, 0, and -9. Okay, and then we go back into stat. We're going to go over to calculate, and we're going to do our quadratic regression, which is number 5. I'll just go down there and highlight it so you can see that. Push enter. All of our data, our x's are in list 1, y's are in list 2. Go down to calculate, and it will tell us, and again, it gives us a perfect quadratic equation here, which is -1 x squared plus 6x minus 9. -1 x squared plus 6x minus 9, I believe, right? Yep, minus 9, and that's y equals. And that is the equation of this graph. Okay? All right, we're going to do one more example. But before we do that, let's do a quick little comedy break. Okay, so last example here we're going to do is example 17 here. Find the equation of the quadratic whose graph cuts the x-axis at 1 and 5 and passes through the point 2, 6. Give your answer in the form y equals ax squared plus bx plus c. So you don't have to draw this graph, but it's kind of handy to sketch it so you kind of get an idea of what's going on. So here's one of our x-intercepts at 1, 2, 3, 4, and then here's another one at 5. And it also says the point 2, 6 is in there. So somewhere roughly up there. So then we can just do, oops. It's going to take me a while to get a good graph going here. So we end up coming up with our quadratic. That's not good. I'm going to get this. So we go up here and we're going to come back down and go through there. Just pretend that that goes through that point and that goes through that point there too. So we have these points here. So this point right here is at 1, 0. This point here is at 5, 0. And this point here, they tell us, is 2 and 6. So we just go into our graphing calculator and enter all of our data in. We got 1, 5, and 2. So 1, enter, 5, enter, 2, enter. And then over here, we got 0, 0, and 6. 0, 0, and 6. And then we go into stat. And we're going to go over to calculate. And we're going to do the quadratic regression, number 5 there. And we will enter down through and push enter, and it gives us that we get negative 2x squared plus 12x minus 10, and it makes a perfect quadratic here. So we got negative 2x squared plus 10x minus 12 is our y, right? Negative 2x plus, oh, I switched the 10 and the 12 around. 12x minus 10 equals y. Okay? All right, and that's the equation for this here. You can do that with any 3 points that you think will make a quadratic equation. You can always put it in the calculator. You can also do it the way we did on the first example there. Okay, if you have any further questions, please feel free to ask in class. Thanks.